All right, so we're going to show DSRC, right? How we use EFF to deliver DSRC on our car.
Okay.
Okay. So we've got our robot here. We've got a sensor at the bottom, reading color. We've got our MCU at the top. This is our computer CAN bus. So we're actually connected just like we would in a normal vehicle.
So it'd be like where they plug in to the port.
ODB2 port. That's right. Yep. Okay. Same thing. That's our CAN bus. We've got our onboard unit for DSRC. So our short-range communications radio on the vehicle. So this is set up exactly like the actual vehicle, exactly like an actual Cadillac or Audi today. So what's happening now is as we drive over different colors, we are generating a CAN bus message out of the computer. It's going through the onboard unit out to the RSU, picked up by the RSU, and then forwarded to an EFF compute node on an 829.
All right, so what's an RSU, by the way?
So the RSU is our roadside unit, and so that's also a CODA device. So we've built the solution and the demos so that we can integrate any manufacturer's DSRC radios into the solution.
Okay, perfect.
Cool. So then we run on this, we have our edge fog fabric on this so that we're able to take the basic safety messages that come out of the CAN bus and process them and do things with them.
Okay.
So we've got our input is DSRC. We're taking in basic safety messages as the input, and then our output is the signs, roadside signs.
Okay.
So what we're doing in the demo right now is we've got a blue stripe on the roadway. We've got a red stripe on the roadway. When we drive over red, we're creating an analog braking message on the CAN bus so that analog braking is enabled. The onboard unit for DSRC converts that into a basic safety message saying that the analog braking is enabled on this car. And then we're accepting that through the RSU to the 829, running local logic on the EFF node to say, if you see an analog braking message, we want to change our sign and reflect that traffic is stopped ahead.
Okay, so when we're not on one of these, we get a don't text and drive or spark for Cisco guys.
That's exactly right. Our default message is display.
Okay, and the red line you said was analog brakes, and what's the blue line?
The blue line is traction control warning. So if there's ponding on the roadway, water on the roadway, the car will trigger the traction control warning. The CAN bus is receiving that and sending it to the OBU. And so now we have a standard traction control warning, when you see it on your dash, where it would actually flash traction control. And then that basic safety message goes to the RSU just like the other one. We receive it here and we change to a different message on the side.
Now, why would I want to do on that device versus, say, in the cloud like I keep hearing a lot of transportation customers talk about?
Yeah, the real importance is we're getting 10 messages per second per car. And so what we have to be able to do is take this data and act on it locally. If we wait until we send it all the way up to the cloud and we analyze the data, number one, we're taking millions of messages per second to the cloud, which is a big capacity issue. We also have to analyze a bunch of messages that aren't relevant. And so by parsing that data as we acquire it from the DSRC unit itself, we now have the ability to look at what's important, focus on what's important, act on it at the edge, and then we can still aggregate data back for long-term analytics.
So you're telling me if I'm driving 70 miles an hour down the road, I don't want to wait for it to go to the cloud and come back?
That's exactly right. We want to make sure as quickly as we can we reflect that there's a problem ahead for vehicles.
All right, perfect. Well, thank you.